Hi, today we're going to be working through question 2 of the Blast from the Past worksheet. So the first question of question number 2, which is part A, says to find the correlation coefficient of these values right here. So the way you do this is by going to your calculator. Calculators are allowed in this question. You hit stat and then edit. And I already put in all the values so that it would take less time. Then when you put in all your values, you can hit stat again, then slide over to calc, go down to number 4, which is linear regression. Click that, yes. And there's our values for everything that we need to know for question A. First, the correlation coefficient, which is the R value, not the R squared. So the second value on there, which is 0.99437. 8 if you round. Then it asks for A and B, which if you look right here, A is the slope and B is the y-intercept. This A in here is negative 1.58, sorry, and the y-intercept is 33,480.3. Now in the next part B, we use the values that we discovered in part A and we create a regression equation. So it asks us to estimate the price of Lena's car given that in rounding our answer to the nearest $100. So she buys a car which has traveled 11,000 miles, and we have to estimate the price which she paid for it. So y equals A, which is our slope of negative 1.58, plus x plus the y-intercept, which is 33,480.3. Then from there we can plug in this value in for x. So I'm going to do that on my calculator. Gives us a y value, which if we remember from the table is the price in dollars, of 16,100.3, but if we round to the nearest $100, which will give us an even 16,100. Now moving on to part C. It tells us that the price of a car decreases by 5% each year, which if 1.00 is 100%, then 0.95 is a decreasement of 5%. So that is our value that we're going to use in our new equation that we're creating. The price of Lena's car after 6 years, that is an important value to remember for the equation. From our previous question, we discovered that her car starts at $16,100. We can multiply that by 0.95, and my work's getting really crowded, and then square that times 6. This is for the 6 years. So that's how that equation works. And if I plug that into my calculator, that gives us the price of $11,834.98. That is her price after 6 years. For the next question, question D, it asks us to find the year which Lena will sell her car when it reaches $10,000, the value of $10,000. So what I like to do for this problem is to use the equation that we created in the previous problem, except instead of having the 6 for the x value, we just have the regular x value, then plugging it into our calculator. So I'm going to write out the equation. That's our starting value. That's how much it decreases every year. And the x for the time. Now if we plug that in to our calculator, and we hit table, then we can see the year, which if she buys it on January 10th, 2010, then it will reach $10,000 9 years later. So the answer is 2019 in the year that she will sell her car, which is this year. So Lena, get ready to sell your car because it's about to go for dirt cheap.